Hey Design Spark, we've got a great video for you today, especially if you're one of those lucky Design Spark Air Quality Project beta testers. Today I'll be walking you through how to set up your kit out of the box before you then go and box it up in your 3D printed enclosures. I'll leave some links below, somewhere down there, to Jude Pullen's article on how to set up those 3D printed boxes. And I'll also leave a link to a couple of articles from Andrew Back that explain in more detail a little bit more about the project software. So, let's get to it. Before we start putting things together, let's take a quick look at the modules that make up our kit. First off, we have the main board, and that's instantly recognisable by the touchscreen on the top. As well as the touchscreen, we also get some physical buttons for user interaction. If we turn our board over, we can see that the main board plugs into a Raspberry Pi GPIO header, and this is suitable for a Raspberry Pi 3B Plus or Raspberry Pi 4. We also have a USB-C connector for power input. You'll want to use a power supply that can source 3 amps or more without sagging. A spare Raspberry Pi power supply with a USB-C adapter on the end will probably do the job, something a bit like this one. The main board also has a GPS module, and there's a regulator for the 3.3 volts supplied to the sensors. This is the Picoblade Esdk adapter, affectionately known as the P board. This cables the sensor chain to the main board. Through the cable we're supplying the I2C signals, GPIO, 3.3 volts, 5 volts and ground. This is the temperature, humidity and volatile organic compound sensor. This is the carbon dioxide sensor, and this is our particulate sensor. In our kit we also have fixings and a DIN rail for the enclosures. Now we know the modules that go into making up our kit, let's start putting them together. We'll start by connecting up the P module. If I bring the connector up to the camera, you can probably see that we have a couple of notches on the connector. So what we will want to do is get our connector, and you can see that on this connector, I put it like that, you can probably see the notches that we have on this connector. So we will need to put this together like so. Let's just make sure that that connector is in properly, and then we will want to do the same thing onto our main board. Now if I bring the main board up, you can see we have the same type of connector on the main board there. There's the notches on that side. So let's match these up. We need to find the notches here. So let's plug these in like so. So we've got our main board connected up to our PEA board. Let's put that down for a second. Now the order of the sensor modules doesn't really matter after the P board. They'll all appear on the bus and feed signals onto the next sensor board, as each sensor board has its own individual address. And the next thing we want to do is to connect our main board to our Raspberry Pi's GPIO header, like so. And now we can connect our sensor boards up. As I mentioned, it doesn't really matter which order you do this in. I can get the connector in there. There we go. What I should point out though is that at the moment these boards aren't hot swappable, so you will need to do your connecting while the power is off. The last thing that we need to do before we can power up our kit is to set up our SD card. Now you're going to need one that's bigger than 16 gigabytes. because we're going to install a pre-configured image onto it. Now there is a plan in the future for you to be able to use a standard Raspberry Pi image and download an installer, but for now we're going to use the pre-configured image. Many laptops have an SD card slot that you can use to program the SD card with. If you don't have one of those, you can get one of these USB type devices that will plug into a USB slot on your laptop or desktop computer, and you're set to go. So let's get to my computer screen and we can configure this SD card. The first thing we're going to need, of course, is an image to load onto our SD card. We can find an up-to-date image here in the installation section of our documentation for the air quality project. So if we right-click on the link and save the link and save it to our project directory, away we go. Now this is a pretty beefy file, so depending on your internet speeds it may take a few minutes. In the meantime, we can look at tools for writing our image to the SD card. First off, we have Rufus, which gives you a lot of control over the process of writing images to a USB stick or an SD card. We also have Win32 Disk Imager, which is quite a simple one to use. But for our purposes today, we'll be using Balena Etcher, which is probably the most popular tool in use at the moment. With good reason. It's super simple to use and very efficient in its operation. If you have an SD card that you want to clean up, you can use the SD Card Association's memory card formatter, although strictly speaking we shouldn't need it today. I already have a copy of Balena Etcher on my PC, so let's open it up and get flashing. So now we have Etcher up and running, and we need to plug in our SD card into either an SD card slot or a USB slot if you're using an SD to USB converter like the one I showed you earlier. So when you do that, if you have an old Raspberry Pi image on the SD card already, then Windows will grizzle that it can't read the Linux partitions. If you have a blank card, of course, you won't see that. But we can ignore these grizzles anyway. Another nice thing with Etcher is that we don't even need to unzip our file, as Etcher will do that for us. And then we select our SD card as the target. Select, and away we go. Depending on the speed of your computer, this process can take a few minutes, so I'm going to use my editing superpowers to speed the process along while Etcher writes and verifies our image. So now we have the image on the SD card, we're going to need to edit the setup file before we can put the card into the Raspberry Pi. But first, we're going to need some information, and that information can be found on an email that was sent to you when you registered. The email should look something like this one, and on it you'll find your credentials. Now you're going to need to copy and paste these because we're going to need them in our setup file. The boot partition of the SD card image can be read by Windows. So if you open up with Windows Explorer, you will see something like this. We then need to navigate to our config file and open it up. Any plain text editor will do, such as Notepad that already comes with Windows, but I'm using a free tool called Notepad++, which is useful for programmers as it respects the file's formatting. So when we look at our file, we can see that it already has the skeleton of a base configuration laid out for us. The first thing I'm going to do is paste that key data that I copied earlier from my email. And we'll talk about that in a moment. So the first thing that we come to in our skeleton file is the friendly name. And that should be changed to something instantly identifiable to you. It's not something that you'll want to change later, so give it some thought. Maybe it could give some idea of the location of the device, or just be something else that's unique to you. There are other identifying parameters that we could add in here. For instance, let me just cut and paste these. We have things like the project. That's particularly useful if you're a makerspace. We have the location, and we have tags as well that tell you something about the location. So we could find this kind of information, the taxonomy for it, because we do have some fixed names for each of these categories. You can find that on the taxonomy page. And going back. But we don't need those for our test, so I'm going to leave those out for now. If you want to use the GPS, you can set this to true. Alternatively, if you're not comfortable giving away your exact location, you could enter some coordinates that are near to you right here. For example, these coordinates are for Leicester Racecourse, which is not far from me. Leave the debug as false. If you want to store data locally on your Raspberry Pi in CSV format, then set this to true. We don't need to do anything with these MQTT broker settings. And that brings us to your private dashboard settings from your email. These will have a 6-digit instance number and a very long set of letters and numbers, which is the private key for your encrypted connection. One final set of parameters we could add are for the public dashboard. The instance here is the email address that you used to register with DesignSpark Cloud, whereas the key is your password from when you activated your account. You will have received an email from Okta with an activation button that would have looked something like this. When you click on the button in the email and follow the instructions, you'll end up with an account to log into, and it should look something like this. When we sign in, we get to our DesignSpark Cloud account, where you can click on our metrics button, and that will take us to our metrics dashboard. And if we click on this, this is our data dashboard. And of course, at the moment we have no data. So let's fix that now. So let's save our file. Save. And now what we need to do is to plug in our SD card into our Raspberry Pi like this. And then we need to power up. Now remember that we need to power up using the USB-C connector, not the micro USB connector on the Raspberry Pi itself. We will also need an Ethernet cable, and that will plug into the Ethernet socket of our Raspberry Pi. Connect the other end to your router. Once we power up our Raspberry Pi and connect it to the internet, there'll be a little bit of a delay before we start getting data onto our dashboard. So in the meantime, let's log into our Pi using a secure shell connection, or SSH. We can do that on a Windows PC with another free tool called Putty. This is another simple tool to use, and the only thing that we need to fill in here is this box here. You can put your Pi's IP address on the box if you know it, or you can just use the host name. In this case, it's quality.local. So let's open that up. And we log in using the standard default logins for Raspberry Pi. So that's Pi and Raspberry. And we're in. Now that we're logged in, let's check that the application is running okay. And hurrah! And now we have some data. Fantastic. We've got our first bits of data. Let's move this out of the way so we can see. No, you can just see that there's our first point on the graph there. At this point, there's a couple of other things that we should probably do. First of which is change our password. We don't want to be leaving a device with a standard password connected to the internet. And probably the easiest way to do that is simply with the Linux password command. So the current password is Raspberry and our new password. So that's better, we're a little bit safer online now. And the second thing that we can do is to get our Wi-Fi up and running. And for that you're going to need your SSID and passkey, and those will be somewhere on your router. Now we could update the WPA Supplicant configuration file in the boot directory, but this is a Raspberry Pi, so let's do it the easy way with raspiconfig. Sudo raspi. And that brings up a menu, which does seem to change every time I use it, but here we go. We can use it using the up and down keys, our arrow keys on our keyboard. And what we want is, and we want to add our wireless LAN. So I'm going to add this and come back to you. So when you've added that, you can just go down to finish using the tab key, and away we go. And we can check that with W. And hurrah, our Wi-Fi is up and running. So now we can remove our Ethernet cable and put our device anywhere we like within range of our Wi-Fi hub. One final thing we can check is our MQTT broker. We can subscribe to it using this instruction here. I'll get it right. There we go. And now we're receiving our JSON data, so we just confirmed that we can subscribe to our MQTT broker. Let's come out of that. Hurrah! So now we're up and running and we're ready to rock and roll. We can box up our kit and place it where it needs to go. I will put links below for all the tools that we've used today. I hope you have a lot of fun with your kit, and let's get improving air quality everywhere. Well, I hope you enjoyed our little quick start guide, and if you have any questions or comments, please leave them below, and please like the video. And all that's left now, I guess, is to say goodbye. So stay safe and see you next time. Bye.